Right, okay, guys. Here we go. We just done 2 by 2 matrices, and by the end of that, hopefully you saw that it wasn't too bad. But let's just do a recap of a 2 by 2. Recap of 2 by 2. Let's pick a matrix. So if A is equal to 1, 4, 2, 3, find the inverse of A. Okay, so first thing we did, we worked out the determinant of A, which is 3 times 1 minus 4 times 2, which in this case is going to be 3 minus 5. Okay, and then you swap the leading, so it's 1 over the determinant. You swap the leading diagonal, so that becomes a 3 and that 1, and then you swap the signs of the other two. Okay, and you can always check on your calculator as well that that will work. Now that's a 2 by 2, not too bad. 3 by 3 is, to be honest, an absolute nightmare. There are lots, it's not hard, but there are lots of steps. Okay, there's lots of steps to remember, loads. And I'll be honest, every time I do it, I don't remember this. I have to basically reteach myself every time I do it. So just be aware of that. It's not difficult, but very hard, quite hard to remember, if I'm honest. And the best thing to do is to use an example. Again, it's exactly the same situation. So if I had a matrix like this, what the inverse is what matrix do I need to times it by that gives me the identity matrix. So we're trying to find this matrix here. That's the inverse, okay? And we'll call this one A. And so the question therefore is find the inverse of A. And again, you might sort of get a feel for what it might look like. But I'm just going to show you the steps because it is hard to sort of decipher this from scratch. I'm going to give you a clear step-by-step guide here. And step 1, similarly with a 2 by 2, it's useful to find the determinant of A. Okay. So you need to find the determinant of A because that does help you sort of reduce the scale down. And in this case, I'm not going to go through the determinant of a 3 by 3, and you might want to stop the video and practice. But in this case, it is -1, or I hope it's -1. Okay, so that's step 1. You find out the determinant. Step 2. We find the matrix of minors, is what we call this step, matrix of minors. So what this means is a massive matrix here. So the top left, so what replaces this 1, it's not the 1, it's the minor matrix, which is the matrix that went with that one when you were doing the determinant. So it is going to be 4, 1, -1, 0. It's the matrix there. So you cross out the row and the column it's in, and it's the matrix that's left. The matrix that's left over. So that's going to go in there. The second one, so the 3 here, the matrix that's left if we cross is going to be 0, 2, 1, and 0. 0, 1, 0. And then the top right one, the 1 there, it's going to be 0, 4, 2, -1. Okay, that's just the top row. Now, if we fill in the second row, put the 0 here, I cross out that row and the column it's in, so it's going to be 3, 1, -1, 0, and so on. Okay, next one, cross out the middle row, I get 0, 2, 0, and then the final column, it's going to be cross out 1. Keep going, last one, 3, 1, 4, 1. You do get quicker at it after a while. Next one is 1, 0, 1. Last one is 1, 3, 4. So just take a little bit of time to understand where that's come from. These are the then you have to work out the determinants of all of those little ones, and just trust me on this. This is what it becomes if I work out the. So we're getting closer. This is what the determinant is of each of those minor matrix. That's called the matrix of minors. Right, that's step 2. We've still got a fair way to go, I'm afraid. Step 3, we then work out the matrix of cofactors. Okay. Now, with the 2 by 2, we switch the signs, and the matrix of cofactors sort of does a similar thing. So again, you need to just, this helps you remember to see what you do. You start with a positive, and it's symmetrical. That eliminates the effect of the sign issue you have when you multiply matrices. So what that means is, basically, whenever you see a plus, you keep the sign the same. Whenever you see a minus, it switches the sign. This is going to be 1. That's going to, the second term is going to switch to a 2. That's going to stay as it is. Then that's going to be a -1. 7. Minus. That one switches. That one stays the same. Okay, so now I've got the matrix of cofactors. I'm now in at step 4, which is I need to write down the transpose matrix, which is otherwise known as AT, or not. It's only A because that's the matrix we're talking about. A. It's got a little t, and basically a transpose of a matrix, okay, basically swaps the columns and rows. Okay, so the first row is going to now be so 1 minus 1 minus 1. This column is now going to be the first row. That is going to be my second row, 2 minus 2, and that's going to be my third row. Okay, so now that is what I've called, that's my transposed matrix, AT, and it is important that you get this in order. And finally, step 5, we put 1 over the determinant, which brings its scale factor back down. So my final inverse is going to be 1 over, I have to go right back to what my determinant was at the start, which was -1. 1 over -1, and this, you'd usually leave it like this, but because this one is timed, that's basically timesing the whole matrix by -1. I can just times every term now by -1. And that will be the inverse matrix. You can always test it out by timesing it by the original matrix, and you should end up with the identity matrix. Okay, but luckily, you can also do this on your calculator. The reason why you need to be able to do it longhand is because they'll often do it in algebra, which you can't use on your calculator. So you can do a 3 by 3. Let's type in the original matrix. That one. It was 1, 3, 1, 0. Okay, now I can just go option mat A power of -1, and let's just see if that was the one. It looks good to me. Just double check it. Yes, that's exactly right. Okay, so the calculator does do it. You don't even want to dream how difficult how long-winded a 4 by 4 inverse is, but it does follow a similar path. Also, I think you can probably see here, there's no steps in here that are hard, really, are there? I mean, every step is fairly basic mathematics, but it's obviously quite procedural. But this is where the power of computing comes in. This process is very, very easy to computer program. I think even if you were to try and do something on Excel, you would be able to do that with not too much difficulty. So it's very easy to program, which again, when you see the uses of this, which happens in the next chapter, you'll see why this is so powerful. It's quite long to do it by hand, but very, very quick to do it with computers. And in this day and age, no one does. I mean, most of what we do in maths is done through a computer. You just need to know how it's done in the background. So that's the power of this. Okay, I do want you to have a look at page 113. Example 18 is definitely worth a read. So do read that one, please, before having a go at the exercise. But I want you to do exercise 6E now, and just do questions 3 to 10 inclusive, okay? And we're not far off finishing this part of the chapter. And so really good work, and I'll see you next time.